Good morning, afternoon, or evening to everyone. Thank you all for attending today's Percona webinar. My name is Christy Ashton, and I'm your moderator. We will begin in just a moment, but I have a few announcements. To make sure you all can hear me, can you raise your hand by clicking on the hand icon in the GoToWebinar control panel? Very good, thank you. All attendees will be on mute for the duration of the webinar. However, please feel free to ask questions by entering them in the question field within the control panel. At the end of the webinar, Matt Griffin, Percona's Director of Product Management, will read your questions for our presenters to answer. We will get to as many questions as we can within our time frame. Those that are not addressed will be answered in a follow-up post on Percona's MySQL performance blog. In addition, a recording of this webinar will be available to everyone within 48 hours. Again, thank you for attending today's webinar, 7 Key MySQL Clustering Technologies to Consider, a joint presentation with Matt Aslett, Research Director of Data Management and Analytics at 415 Research, and Peter Zaitsev, Percona's founder and CEO. Matt, you may now begin.
Thanks, Christy, and thank you everyone for joining us today. Hopefully now you can see my screen, and just to briefly give you a little bit more detail on myself. So as Christy said there, so I'm Research Director for Data Platforms and Analytics at 451 Research. I'm responsible, therefore, for the data platforms and analytics research agenda, so both the back end and kind of front end data integration, data analytics coverage. Although my personal coverage in terms of engaging with clients, both on the vendor and the end user side, tends to be driven more by those, the actual the platforms themselves. So operational and analytic databases, including obviously in more recent years things like NoSQL, NewSQL, and Hadoop. Just very briefly before we get into the main presentation, wanted to just give you an introduction to 451 Research and the 451 Group. You may not have come across the company before, and those two names are used somewhat interchangeably. So just to clarify, the 451 Group is the parent company, and it actually has 3 operating divisions, one of which is 451 Research. The other 2 are the Uptime Institute, which is focused on data center certification events and professional services, and the third is Yankee Group, another industry analyst firm, and one of a number of acquisitions that we've made over the years, as you can see down the bottom here. One of the more recent of those, obviously another industry analyst firm, as I say, focused specifically on the telecommunications space. So 451 Research you can think of as the original part of the 451 Group, now operating, as I say, as a separate division. Another industry analyst, an industry analyst firm focused on emerging technology market segments, with a combination of research, analysis, data, and qualitative and quantitative insight delivered daily. We have about 800 company subscribers, about 8,000 individual subscribers, and the most important number, perhaps, 2,000 plus what we call enterprise IT network members. So those are, practitioners, IT end users, who engage with us as part of our research, both as kind of consumers and helping shape our perspectives on the world of IT. So to get into the core presentation itself, obviously we're talking today about different approaches to clustering, and to us, Peter, obviously fantastic. Looking forward to hearing Peter's expertise in these areas. But what I wanted to do was kind of set the scene a little bit. It's more kind of high level view of clustering in MySQL and some of the trends that we see happening there. So the first point is, I guess, why cluster MySQL in the first place. If we look at the engagement we've had with clients over the years in various kind of industries, obviously we see a huge adoption of MySQL, particularly for new applications, web-facing applications. A great starting point for those kind of applications. Various reasons for that. Obviously, it's open source, it's easy to use, and it has a great ecosystem of pools and also support providers out there. So still a good choice, particularly for those kinds of applications. And in terms of kind of scaling it and enabling people to start small and grow big, the initial approach to scaling was always fairly straightforward. As with actually a lot of other kind of traditional relational database technologies, as the application becomes more and more successful, as you add more users, whether those be external consumers of an application or internal business users, you get a bigger database, or you put the database at least on a bigger, faster server, and that helps you to scale, particularly if you then kind of tune the hell out of it and make sure that the database is able to take full advantage of that bigger, faster server. What we found, though, and this has come up a number of times with clients that we've talked to, it can result in then kind of a constant maintenance requirement just to keep that database performing as required. And what we see increasingly, through clients and in the general industry, is that scale-up approach is just not suitable for high performance database requirements, particularly as we look at more newer application types that have emerged in recent years. The interactivity that's required for new social applications, mobile applications, means that pace of potential user growth, or the pace of potential user activity growth, and also the need to deal with a multiplicity of data types, is just too great for that traditional kind of scale up approach. And what we see is, we see this over and over again, is that that adding a larger database, just expanding the size of the database server, really just delays the inevitable, which is the need to think differently about your database architecture requirements. If we think about thinking differently about database architecture requirements, this graphic illustrates something we've been talking about for a couple of years, which is the idea of kind of sprained relational databases. Now, a sprain is an injury, in this case, to the kind of the tendon in the foot, which is caused by it being stretched almost to breaking point, but not quite. Certainly beyond the normal kind of usage. And this actually, we use this because we think it's a pretty good analogy for what we've seen happening in the database space over the last 5 years, definitely, which is the relational database has taken on different capabilities, things like object support, XML support. It's also, if we think about the shift towards more distributed architecture, people are kind of expecting the relational database to be able to take on board new applications, deal with these new interactive applications. And what we see is that a lot of databases or indeed database administrators have got to this potential kind of breaking point in terms of keeping the systems up and running. We saw this initially, a report we wrote back in April 2011, assessing kind of the drivers behind the development of new database technologies, things like NoSQL and NewSQL. We followed this up with a number of reports in recent years, in May 2012, July 2013, looking at some of the trends and dynamics in the emerging database space. And this, as I said, this kind of concept of database sprain has really kind of been one of the core things that has kind of driven our research in this area. As I say, what it's driven by is kind of those interactive applications, meaning that the pace of growth is too great for the kind of traditional relational database model, perhaps efficiently absorbed by scaling up. Obviously, SPRAIN is, as you can see here, is also an acronym, and it stands for kind of the 6 key aspects of kind of tension, if you like, that database administrators are dealing with. Those being scalability, performance, relaxed consistency, agility, intricacy, and necessity. And not all of those impact, every application, all of those impact every organization, every database deployment. But certainly we see it often when we look at organizations that are rethinking their database architecture. It's a combination of these factors, maybe not all of them, but a combination of two or more, which is driving this increased willingness to look towards emerging alternatives. So if we take it as read, as we described, that the scale-up approach by and large is kind of not suitable for kind of the new breed of high performance database requirements, then what are the alternatives? So obviously, if it's appropriate, then NoSQL is one of those alternatives if the application type is suited to a NoSQL database. Clearly, whilst we see a lot of those, that's still in the minority, and especially when you think about existing applications. And so therefore we see a lot of people turning towards what we kind of gave an umbrella term of NewSQL, and NewSQL actually divides into a number of different categories. There is new SQL relational databases designed specifically for more scale-up architecture. Also kind of a new breed of MySQL storage engines, and advanced approaches to kind of clustering and sharding. So obviously those last two are the primary kind of aspects that we're thinking about in terms of this webinar, although there's a certain amount of overlap as we'll come on to discuss. So if you think about the clustering approaches that organizations look at in terms of enabling this advanced scalability and performance, the key point, I mean, obviously the title of this presentation is about seven different approaches, and obviously Peter's going to go into a lot more detail on those, but just wanted to run through those seven as we see them and get some kind of high level considerations about what we see organizations are thinking about when they're considering their options in terms of clustering. So, those seven, to start with replication-based clustering, for example, PRM and MHA. Then there's kind of storage level replication and shared storage based, upon that storage level replication. So things like DRBD and obviously storage area network based technologies. Synchronous replication, in particular, we've seen a lot of interest in just the most recent years, in particular in Galera cluster, and obviously Percona's extra DB cluster variant of that. External replication based would be number 4. Continuant, obviously one of the primary vendors in this space with their Tungsten offering, particularly in relation to MySQL. And the fifth one is we would refer to as kind of proxy-based clustering, and I'll touch on this a bit more, and I know Peter will go into more detail. But companies, you may have come across some of these companies like Scalebase, Scalark, Tesora, and also the MariaDB project MaxScale, enabling this approach. I mentioned obviously MySQL storage engines is a kind of a category, if you like, in itself amongst NewSQL, but there's clearly overlap in terms of clustering via storage engines. There's a few still out there. Perhaps the MySQL storage engine ecosystem isn't perhaps as vibrant as it once was, but clearly there are still some decent options out there. MySQL cluster, I think, obviously being one of the most prominent, and has Oracle have been pushing that quite heavily actually in the last couple of years compared to what we've seen in previous years. So another one to consider. And finally, again, in terms of kind of the overlap of categories within NewSQL, MySQL compatible NewSQL databases. So there's a few here: Clustrix, MemSQL, GenieDB, for example, which to a greater or lesser extent have been developed to take advantage of either MySQL storage engine or the MySQL protocol to deliver a new new database architecture, but provide compatibility with those MySQL applications. So as I say, Peter's going to go into a lot more detail in terms of the kind of technical considerations about some of those approaches. So I just wanted to run through perhaps some of the higher level considerations that we see that are impacting the way people are thinking about making use of some of those technologies. There's a long list, as you see here, of things potentially to consider, and you can kind of divide them up between kind of technology and more kind of process kind of user-driven considerations. But if we look at it from a technology standpoint, I think is it fit for purpose? What are you trying to achieve with your approach to clustering? Is perhaps the most important question you can ask. Then there's things like synchronous or asynchronous, the implications of slave lag, the implications in relation to your backup strategy, how scalable is that, the scalability, recoverability, obviously an important aspect as well, depending on the approach and, as you say, what you're trying to achieve. And increasingly, we see organizations thinking about not just local clustering or scalability, if you like, but distributed multi-data center clustering, and that is clearly another step and a significant kind of consideration in terms of the capabilities that are available. So talk about, as I say, kind of some high-level considerations and what to think about when you look at those 7 different choices from a clustering perspective. The first point to make is that scalability is clearly one of the main reasons why you would think about clustering, as we've already talked about. But it's important to note that it's not the only one, and we also see organizations thinking about clustering for high availability. Instead of actually necessarily scaling out to achieve greater performance, actually using high availability to deal with issues when you have a database server drop and have some of the slaves take over and can ensure that you can continue your operations. And the key point here is that not every use case requires both scalability and high availability, certainly not necessarily both at the same time. Some of the technologies that we will talk about in the webinar attempt to achieve an element of both, but it is, I think, we talk about that first consideration. What are you trying to achieve? Are you primarily thinking about scalability or primarily high availability? And that will certainly be a key consideration in driving the way you think about the available technologies. Just to pick through a few kind of key issues that we see organizations that dealing with that we've spoken to. Synchronous replication, obviously, as we mentioned, is clearly a very popular choice when you start thinking about clustering approaches. On the positive side, good for simple failover, limited write scalability. On the negative side, on the negative side, not a true backup solution, not a true scalability solution. I kind of hesitated there to say on the negative side, I suppose it's not necessarily a criticism, it's just a statement of making sure you're aware of what the technologies are good for and where they're best positioned. On the other side, kind of asynchronous replication, very good for scaling read queries and improve availability. On the negative side, that asynchronous replication can lead to write slave lag, and it's not necessarily a backup solution. In terms of slave lag, that is something we've seen, a lot of organizations deal with. They obviously start off clustering at a fairly small level. Can be fairly straightforward. As they begin to grow, as the application usage begins to grow, they can run into serious difficulties in relation to slave lag. And it really is something that I think we see companies now having the position where they need to prepare for that up front, or need to think about that up front, and at least be thinking about the fact that potentially eventually you may hit a wall with that approach and may need to think again. Another popular approach, obviously, is read-write splitting. On the positive side, we've seen definitely better utilization of the available resources. Again, though, on the negative side, that asynchronous replication can potentially lead to slave lag, and obviously something to take into account. And then, sharding in general, obviously on the positive side, definitely we've seen some good successes in terms of increasing scalability to serve high traffic websites in particular. On the negative side, it may require an application rewrite, and we've seen some examples of organizations where, although sharding was kind of the obvious next step to take, they kind of were quite wary of that because they didn't want to impact the application, have to rewrite the application and deal with potential performance issues and compatibility issues. For that reason, we have seen cases where organizations consider it actually a temporary fix, because obviously the more success you have, potentially the more you have to shard, and it becomes again, the sharding and management of those shards becomes the issue itself, not the management of the core database. So you just kind of transfer the problem for a little while and put it off. In particular, obviously, if you're dealing with master-slave clusters, it leads to an additional complexity, which isn't actually fully kind of illustrated in this graphic. But clearly, there are some significant implications and significant potential problems that can arise from dealing with sharding if you don't manage it properly and have the right approach to begin with. Also, just wanted to mention, I mentioned that the proxy-based approach to things like ScaleArc and Scalebase and MaxScale. We've seen some companies beginning to take this approach. Obviously, on the positive side, you have this policy-based sharding layer and additional management layer, which helps perhaps alleviate some of the complexity I just talked about in terms of sharding and shard management. I guess, I put it down as a con. It's kind of at least a consideration rather than necessarily a negative. It does obviously add then another layer of complexity to the stack. Not every organization is necessarily going to want to take that route, and there's a potential for say compatibility issues. Not so much compatibility, because I think all of the suppliers in this space are focused on MySQL protocol compatibility, but clearly, if you're taking an existing application, moving it to a new architecture, you need to be aware that there potentially is there could be performance issues. You have to clearly kind of test that compatibility to make sure that you can deliver the same kind of service and performance that your users will be expecting. So there's some of the key kind of technological kind of further considerations. I mentioned also clearly here that there's a big group of user-related kind of considerations as well. Performance, I mean, I already kind of touched on that, but that comes down to obviously a choice from the individual organization or end user or database administrator about which approach is going to deliver the best performance depending on the individual application. Maturity obviously is something to consider. There's different approaches, there's different technologies and tools that are related to the approaches that I talked about. Some of them are obviously relatively new, and one thing we see repeatedly when we talk to end users, they want to know how mature is the technology, the software, and in particular the maturity of its adoption. So who else is using it? What are they using it for? To what extent are they using it? So that's obviously a key consideration we see coming up again and again. Administration, monitoring, and management, obviously a key and important aspect as well. How easy is the actual the software to use, and how does it improve the monitoring and management experience? I talked about compatibility with existing applications. Obviously, that means at a fundamental level means will they continue to run, but also it could mean at a more fine-grained detail, do you get the kind of experience you expect, particularly from a kind of performance level. Flexibility and adaptability is something to think about as well. So will the solution that you choose, does it not just solve your problem today, but does it enable you to continue to expand and fulfill your potential kind of application development roadmap for that particular project, and obviously the business trends as well, making sure that you can fulfill some of the business goals. Ease of use, I think, obviously fairly straightforward, and also support training consulting, fairly straightforward as well. Obviously, some of the technologies in the space, in the MySQL ecosystem, in fact, many of them are open source. Obviously, that is not necessarily criticism. Obviously, a lot of them are very good, but if you're talking about deploying alongside a production application on your database, you want to make sure that there's a vendor out there, or at least a community out there at the very least, that is able to support you, and you're able to make sure that you can get the training consulting required to get that system up and running, that clustering approach up and running, and continue to benefit from it. So that's just a very quick run for you, really. As I said, some of the high-level considerations, and obviously going to hand over to Peter and to get his perspective on some more fine-grained detail in terms of some of those approaches. Obviously, we're having I think we're open for Q&A at the end of the webinar here, so happy to take questions then. But just to say, if you have more questions either on what I've talked about, or obviously 451 Research itself, there's my details there, and you can you can contact us and ask the questions there. But for now, I thank you very much for joining, and I'll hand over to Peter to take you through the rest of the webinar.
Hello.
Very good. Go ahead, Peter.
Thank you. So let me cover my part. And as much as said about me going in much more details, there is little time I have, so my in-depth technical details will be some, I think, valuable things which we learned as a practical experience here at PeerCon, where I wouldn't have a time to go through at a very all rundown of all technical details for specific solutions. First, I wanted to talk about why people want to cluster. Really, when we talk about a lot of our smaller customers, they are quite happy with single MySQL systems, right? Because they're very easy to deal for developers, for operations, easy to manage. There is a lot of tools, but unfortunately, it doesn't work as if the application become more business critical, because single node obviously can fail. Or they don't work in terms of scalability, right? Because when you have their larger systems like Facebook, for example, they surely cannot be handled by a single MySQL node, even very powerful one. So we go to clusters either because we need to have ability for our application or scalability, and in many cases it is both, because large-scale applications are always mind their downtime. Now, when we speak about the scalability, it's worth to understand in terms of solutions. We may need to scale reads, writes, data size, or combinations of thereof. I think people understand reads and writes very well, right? I mean, some applications are more read-bound or write-bound, but I think for many, needing to scale because of a data size can come as a surprise, and then may essentially run into that as a wall. If you think about the MySQL, even if you can handle traffic reads and writes, over time it becomes too hard to manage. For example, having 10, 20 terabytes of data in single MySQL node just becomes a nightmare, and you may need to take some special solution driven by having too much of a data which complicates your operational process rather than anything else. Then we speak about the cluster. It introduces a lot more moving parts and complexity. When you have a cluster, at least you will have multiple nodes being involved, either for scaling or and havability, and some communication mechanism between them, which I will call network, which means there is much more moving parts. There are a lot more mistakes and potential, as well as a lot more potential for hardware failures, software failures, and bugs, because for every single component, the probability of failure grows higher when there is more component. And we have to consider how that impacts manageability of a cluster. Another thing what we find out is what in a lot of cases people invest into deploying the cluster, but they are missing out either on testing or on training their crew on using appropriately cluster technology. And then in this case, cluster becomes the solution for low availability instead of high availability. In fact, single MySQL node actually can be pretty resilient. We had reports for guys like Facebook, for example, when they see for a single MySQL node, their mean time between failures was something like several years with proper hardware and proper operational. This is a lot of time, right? And if you are deploying the cluster without proper testing and proper training of your crew, you may end up having much lower numbers with that. So we would really recommend our customers to invest a lot into that. Another concern with clusters, especially larger one, is automation. As we spoke, clusters typically would include multiple nodes and a network, and all of and many moving parts. So if you don't automate things, you will have extreme pain in your operations, which in the end will cause mistakes and will very likely cause the downtime due to those mistakes. Again, that is a very important part when it comes to cluster. So when we speak about the automation, need for automation, we are looking at for two main reasons. One is what we see with deployments is what companies have their MySQL and general IT infrastructure scale growing much faster than amount of employees they have which are managing that. So we really looking for more and more efficient solutions every year. When single DBA or system administrator will be able to responsible for 10, 20, 50, 100 of the different MySQL servers. We also need a consistency, because if we're not able to manage our different systems in a consistent way, maintain the same configurations and so on and so forth, we are exposing us to the zoo, which has all kind of security implications with much more chance for problems happening from a different configuration, so on and so forth. So if you are running the cluster, you will really need to think about automation for those items and other things. Now, when you look at the clustering solutions, I think it's very important to understand there are essentially two different kinds of clustering solutions which have benefits and drawbacks. I would call one of them tightly coupled and another more loosely coupled. The tightly coupled systems are great to work with. They're seen as a single system. It's simple to work with. An example of those may be something like a MySQL cluster. But the danger for that is because it's a tightly coupled system, there is a larger chance of failures which will take the whole cluster down. For example, we have seen a number of cases when some sort of software bugs will trigger some bug in software, and the whole MySQL cluster will go down together because it's so tightly coupled. Another clusters which may be built more loosely coupled. Think about the MySQL and replication slaves, for example. They are very independent, right? Besides just their replication stream going between them, and in most cases, something happening with a single node does not impact the other systems. But also, what this loosely coupled means is what they are seen as multiple systems which are sort of managed separately, and that may be harder for development and ops guys, but they are a lot more resilient due to that. Let's talk a bit also about the replication types, which we see with different clusters. And there are multiple modes of replication which MySQL solution can support, which have all some potential issues. The synchronous replication is great, but the problems with that often can come up as a performance, especially if you're trying to run synchronous replication at their cross data centers scale. The asynchronous replication has a problem with consistency, and the most known of that is a slave lag. Right? We have data on the master, and then it takes a time to make it to a slave because of asynchronous replication. That means application may read the data which is no more true, which can cause problems for certain applications. Right? Think about that as a bank account where you spend your money, but you're still reading the data from the slave, and you're seeing they're still there. Not good at all. Semi-synchronous. This is it's good to note what semi-synchronous is really asynchronous replication, contrary to what the name implies. It is asynchronous replication with better abilities for us to recover in case of master goes down. And there is also the term you may have heard, virtually synchronous replication. This is also asynchronous replication, but in addition to better recovery, which semi-synchronous replication gives us, it also helps us with conflict preventions. I'm not giving in a lot more details about what they are. I'm sure you're all familiar with Google and can read more about what it is. Another challenge what we see our customers come across is how do they think about the failover process in the cluster, especially for MySQL replication-based cluster. And in this case, we're really thinking about the two different problems. Okay, first, who decides whether we actually need to do a failover? Because sometimes the failover causes solves a problem. In other cases, it doesn't. For example, if your hardware on the slave server failed, you want to failover. Now, if you just deployed the code which throws some very nasty queries at the system, there is no reason to failover because you will just kill the slave the same way as you killed the master, right? Taking that decision is one question, and actually doing failover wherever it is scripted and it's something what I would call as a press button failover is one thing, and or wherever it's multiple step to change your replication to point from master to the slave. These are important conditions, and we see depending on the application, people may take one or other decision on those concepts. Now I reviewed some of the questions you may be asking about MySQL solution. Now let me go through some solutions which exist in MySQL world. There is a set of MySQL replication, built-in replication-based solution. In the answer, properties are it's asynchronous or semi-synchronous. The application must be replication aware for scaling, and really only reads are scaled by a MySQL replication because all your writes have to go to the master. We have some proxy solutions which can help with applications to route reads to the slaves, but they don't quite handle all the cases. It's very complicated to build a solution which will automatically understand wherever this given transaction will do any writes or not and route it appropriately. So for best scaling results, you will need to have some application support when you deploy MySQL replication. And also, MySQL replication is often used in combination with some other technology to create something like a building block, or sometimes referred as a cluster or pod or something else with a sharding technology. In terms of management tools for replication, there are multiple solutions which exist. There are the well-known tools of MHA, which is command line tools for managing replication. And this tool was very much focused on how to pick up the right slave. We also have a pacemaker based solution called PRM, or Percona Replication Manager, which is a little bit more complicated to work with, but it's based on pacemaker, and it can handle very complicated failure modes when you have network partitioners or some asymmetrical network failure and so on and so forth. Oracle has now provided us with MySQL replication utilities, which are wonderful if you're using MySQL 5.6 with GT IDs. And then also we see a lot of people using some homegrown solutions to manage their replications, which target specific needs, or they're just legacy because they haven't been developed 5 years ago or more, when haven't been such many solutions for open source solution exist. Then there are a number of external replication solutions. Matt already mentioned continued tungsten, which is indeed their most common solution out there, but there are some others. For example, symmetric DS can be used for then you have a massive many-to-many synchronizations. For example, you have a database at the point of sales, which can be measured in tens of thousands, and some central database. We also see sometimes homegrown solutions deployed for the very specific replication environments, which can be done either using MySQL triggers or based on timestamp in the tables, or even the parse and a bin log. By the way, their Oracle a year or so ago released their special API, so it becomes less painful those days. The next solution you may be looking at is a storage level replication technologies. You can think about DRBD, SAN, NAS, cloud storage, which essentially replicates your data stored on a file system. And in this case, you can use that as an active-passive solution for a database. This active-passive is really the main problem with such approach, even though many enterprise companies like this because they are very familiar with this technology, and it was in use for many years for all kind of different database technologies they use. The problem with active-passive is, of course, you have a waste of resources, because now you have the copy of the data and standby server nobody runs out there. There is also performance overhead with the storage rights because they have to be replicated, and also long failover times if you were to restart a MySQL on what used to be just a copy of the data. It will have to do the crash recovery, it will have to warm up at buffer pool, which all takes time. In terms of MySQL cluster, we are using that solution for high availability and scalability, and it's wonderful. It has both built-in replication and sharding. The challenge of that technology, it's tightly coupled, so there is a risk if you do something wrong, you can bring the whole cluster down, as well as it's actually rather complicated, and it's not very cloud friendly, because it performs best at a very high performance dedicated network. Even though there have been a lot of work done with cluster recently, which makes it more usable. When I speak about management tools for MySQL cluster, there are two great tools for that. Either MySQL Cluster Manager, which is available with subscription for Oracle, or Cluster Control by Several9, which you can either get from Several9 directly, or it's also available through Percona with our support subscription. The more newer solution for clustering in the MySQL space is Percona XRDB Cluster, which is our product, open source, and also our Galera-based technology. So it really is a very appealing solution for a lot of the small and medium-sized installations, because it's based on InnoDB tables, which are very well understood, and it's based on your existing team experience. It can use virtually synchronous or synchronous replication mode, and it's loosely coupled. You get all the data and every single node. That means if something happens, it's a lot easier to troubleshoot with clusters and bring them back online than it happened to some more complicated technology. It scales reads, and it only scales write to a certain extent, so it also can be used as a built-in block for sharding for very large systems. Another great thing what we here is what it is very cloud friendly, because it doesn't require doesn't place a huge demand on a network communication. It's very optimized by doing communication on writes and only on transactions commit, only performing all reads locally, which is again very well appreciated, not having those extra dependencies. Now, as I mentioned, for MySQL there is really no silver bullet, and this solution is not perfect either. you may not use this solution if you have transactions which have changing tons amount of rows, right? Like million of rows in the single transactions, because it wouldn't scale well on this solution. It also doesn't have online DDL as some more mature cluster technologies at this point, even though this is something what we are working on right now. When it comes to management tools for MySQL cluster, we have solution from the several lines, which is, I believe, is a market leader when it comes to the graphical user interface management tools. They are available with Percona support, and what is wonderful about them is what they support all Galera technologies. Wherever you use Percona XRB cluster, MariaDB Galera cluster, or MySQL with Galera patches, it can work with all of them. There is also a new development which is was out there just for a couple of months, which is a MariaDB Enterprise. It is rather early, not very mature release right now, and its functionality is only limited to MariaDB Galera cluster at this point. Another direction what we can see is a MySQL compatible NewSQL solution, as Matt called them. Cluster, MemSQL, GNDB, ScaleDB. I think it's very interesting technologies, but looking at those, you have to really understand to what extent they are compatible with MySQL, because implementing basic MySQL protocol support is easy. Having the very intricate compatibility of every single MySQL function is a lot harder, and if you deploy one of those, it's very good to test how it works. When it comes to sharding, well, this is essentially the solution what you have to do when you go on the large scale. I mean, as I mentioned, you cannot really build their Facebook with a single node. What sharding is in MySQL world is really many multi-server horizontal partitioning, which can be done, can be either built in database engine or be manual. And as I mentioned, we often see people really use that together with other clustering technology, either spreading that to clusters which are built on the MySQL replication, or spread over clusters which are based on the Percona XRB cluster. So what are solutions for sharding which exist out there? Well, there are some solutions which are have a sharding built in, like MySQL cluster, Clustrix, Spider storage engine. A lot of people, like really this is probably the most common way, is have some ad hoc solutions which they have developed in-house. Some people have outsourced some of them, like Hive, Vitess, JetPants. These are open source frameworks which have been developed by some other companies and open source them. There are also a number of solutions which are doing that on the proxy level, ScaleArk, Tezora, MySQL Proxy, MaxScale. The maturity of this framework depends. Some of them really have some ready-to-use implementations. Others, as MySQL Proxy or MaxScale Proxy, say, hey, well, you can potentially use this proxy to implement sharding solution for yourself, but you'll have to put a lot of work into that. Another interesting development, which is also very early now, is the MySQL or Oracle effort called MySQL Fabric, which is a special API to help to shard MySQL and also manage highly available clustered MySQL on large scale. I would recommend to watch this closely and see how it develops. Finally, let me talk about getting help with those solutions. As there is a lot of complexity with choosing the clustering technology, and there are multiple vendors which are available to help with open source products. We support a lot of them. The most common one at Percona through our support consulting and remote DBA. If you are starting an evaluation process for clustering, I would recommend you to engage with somebody who has experience in making those choices early on, because if you make a wrong choice of clustering technology, and then in a few months when you put your application in production you hit the wall, that can be very expensive to rebuild that ship while it's sailing. So engage early. Let me mention a couple of other things. I have provided their very brief coverage of a clustering technology for MySQL. There is going to be a lot more said about large amount of the technologies mentioned at the Percona Live, which takes in Santa Clara next week. If you're interested about that, we really welcome you to attend. And if you are interested about CentOS and OpenStack specifically, we added their free open source appreciation day event on March 31st, which is the next Monday. You are encouraged to attend, and attendance is free. On this note, let me say thank you for listening, and let's transfer that to Matt for questions.
Thanks, Peter. This is Matt Griffin joining. We really appreciate both Matt Aslett and Peter Zaitsev for their presentations, and thank you to the audience for joining. We've gotten a few questions, and we've got about 10 minutes to go through these questions. So if anyone has any other questions, please post them in the questions dialogue, and we will get to them. Anything that we don't get to, we'll have a follow-up blog post on the MySQL Performance blog with answers. So with that, we'll begin with you, Peter. Which cluster can we use to scale writes?
Which cluster can you use to scale writes? Now, if you look at the scaling writes, there is some limited scaling of writes you can get with BXC or Galera scaled, Galera-based technology. By limited, I mean maybe if that can help you to scale writes, maybe twice to what a single node can handle. Their scaling writes on the highest scale is either achieved through sharding, either explicit, done in your application, or which happens inside the clustering technology. MySQL cluster, their Clustrix proxy-based solutions such as ScaleArc and ScaleBase can help you to scale writes on a higher scale, as well as running out your own sharding.
Okay, thank you, Peter. Getting more questions. This is probably first to Matt, but also Peter, if you could follow up on this question about new SQL technologies. Can you tell us about the adoption of new SQL technologies like Clustrix or MemSQL, and are they best used in specific use cases or environments? Anything you kind of expand on MemSQL also would be great. So Matt, is there anything you kind of have to say about new SQL technology adoptions like Clustrix and MemSQL?
Yeah, I mean, the first point to say is I think we're still at very early stages. If you look at, you compare to, I mean, we're still at early stages of NoSQL adoption, but if you compare to some of the developer-led adoption of NoSQL, I think the new SQL, vendors are a little way behind. I think there's a few reasons for that, to do with kind of developer traction definitely being one, but also, of course, if we're talking about deploying a new SQL relational database in a production environment, there's certain perhaps hoops that have to be jumped through. There's definite kind of processes that organizations will have in place to, and so the deployment cycle seems to me to be longer than it certainly is the case for NoSQL applications, where you might, certainly you can see that a lot of organizations are dealing with not necessarily as mission critical, certainly non-transactional applications. So there's a longer life cycle. We definitely do see some adoption. We're seeing some growing interest. In particular, I mean, the question there asked about MemSQL, Clustrix, DB, and some of the others in this space. We particularly see them being adopted for what we call kind of operational intelligence, but some people call, kind of real-time analytics applications, where you're using them not just for the operational database, but to also do some analytics against that data prior to it actually then being kind of transferred and ETL'd into the data warehouse. So not as a replacement for your traditional analytic environment, but as a complement for more kind of real-time data analysis, as we say. So yeah, it's early stages, but I think we definitely see some growing interest, and in particular, as people look towards more kind of distributed architecture, I think we might see some growing interest in those technologies.
Peter, anything to add about the new SQL category?
So I will add just one brief thing. I think what there is more adoption than you may see in the media, blogs, and so on and so forth, right? Because if you look at the new SQL technology, majority of us are proprietary solutions. A lot of them are really deployed in this enterprise environments, which are not as public about what they're using and why, right? Compared to a lot of, I would say, web startup and kind of other deployments where we deploy or see open source solutions deployed and people openly writing about them. Hey, we deployed this, these things work for us, this didn't, right? So just looking at amount of mentions in the media cannot be used very well to represent the deployments of those technologies.
Thank you to both of you. Peter, this question is to you. I'm using MySQL cluster now. Why would I want to change to ExtraDB or work on an ExtraDB cluster?
Well, that's a wonderful question, right? I think the question here is, well, is it working well for you, right? If it's working well for you, solves your problem, then you don't need to change what is broken. We have a number of people who actually moved through a MySQL cluster to the Percona ExtraDB cluster, mainly due to the operational pains. Some people have deployed cluster, years ago, but if they can be struggling with having some problems they don't understand and can't resolve every so often, or have some performance issue they kind of had to live in. So that is the major reasons to have Percona ExtraDB cluster. But again, I want to be practical in this case. There are a number of cases when MySQL cluster is better solution than Percona ExtraDB cluster, right? So not every single application needs to be migrated.
Thank you. Peter, how do cluster solutions handle queries with many joins?
Oh yes, that's a great question, right? Yes, well, I would say if you think about this NoSQL solutions and how wonderfully they handle sharding, well, because many of them don't quite do the joins is exactly why. Because joins are pain in the ass when it comes to distributed databases. Now, in MySQL, when it comes to clustering technologies, you have to look at wherever the technology actually does sharding or it doesn't. If you think about the Percona ExtraDB cluster technology or MySQL replication based, then in this case the joins can be implemented locally using the standard MySQL optimizer process, which is very well, and it works wonderfully. When it comes to doing joins on a distributed database, then in this case, solutions vary. In case of MySQL cluster, performing joins was really one of those big performance problem issues, which is being improved in a recent cluster release by pushing out some join execution back to a data node and having some intelligence about the data distribution. If you think about solutions like Clustrix, they have their own optimizer, which creates a distributed plan which can resolve queries very well with clustered environments. If you think about the proxy solutions which do sharding, they often also try to do some intelligence, but operating on a proxy level, you don't really have as much intelligence about the data as the database engine can have, right? So their handling of a distributed query plan have to be a little bit more limited than that, than engine itself could do.
Okay, we have time for one more question also. If anyone has any other questions, please continue to post them in the dialogue and we'll answer them in the follow-up blog post. And this question is for Peter as well. Can Percona XtraDB cluster be deployed across availability zones in AWS? For example, is latency an issue?
Well, yes, that's a wonderful question, and this is indeed rather a common deployment with Percona XtraDB cluster, having a clusters which spawn availability zone or even geography. What you have to understand in this case is what Percona XtraDB cluster network latency demands are a lot more modest than those for MySQL cluster, for example, because it only have to do essentially network round trip when a transaction is committed. So if you can handle a little bit of latency on writes, on transaction commits for writes, then that can be a very good solution for you. We have some applications, for example, when people are quite okay with having, let's say, 100 milliseconds latency for writes, right? Then, for example, I put the new article on a blog post. I don't really care about waiting that much. And in this case, you can create a cluster which even spawn the geography and work quite well.
Great, great. Everyone, thank you for your questions and thank you for attending. That's all we have time for, and I'll hand it to Christy to wrap up.
Yes, once again, thank you, everyone. Thank you, Peter and Matt Aslett. Be sure to register for Percona Live and Open Source Appreciation Day. It's just a few days away, starting next Monday and going through Friday, April 4th. Our next webinar is Wednesday, April 16th, again at 10 a.m., called Optimizing MySQL Performance, Choosing the Right Tool for the Job, presented by Percona's Ryan Lowe. Percona resources are always available to you on our website and the MySQL Performance blog. Again, thank you. Our webinar will now end.